Hi, my name is Edith Martel and I'm a project geologist with the Northwest Territories Geological Survey. Today I will present an overview of the various facets of the multidisciplinary NUNACHO project located in an underexplored area of the Southeast Northwest Territory here. To tackle this poorly understood area of the NWT, we gathered a team of experts to answer fundamental scientific questions about the geological evolution of this area. It is the expertise of all of these scientists listed here and the collaboration between the various working groups that make this project a success. Throughout this presentation, I will guide you through finding the posters and talks related to this project. Our work focuses on the Ray Craton here, which amalgamated during the formation of the supercontinent Nuna and is now situated at the core of Laurentia. The Ray Craton is sandwiched between the Hearn Craton and the Slave Craton, and although the Ray Craton may have looked similar to the Slave and Hearn in the Neo-Archean, it is now much different because it has been affected by several periods of orogenesis, as well as sedimentation in the Paleoproterozoic. Our work focuses on the western margin of the Ray, so I'll hide the eastern margin here. And the Ray Craton has been divided in various blocks, and of interest to our project is the South Ray block, the Queen Mud block, and the Tolson basement complex. Very little is known about the area here around the Nacho Lake. The area of interest here is bounded by the Thelon and the Tolson orogens, and an older orogeny that also affected the western margin of the Ray Craton has been initially recognized in the Queen Mud block and the Tolson basement complex, and it is termed the Arrowsmith orogeny. Other key geological features are preserved sedimentary outliers of poorly constrained mid-Paleoproterozoic ages, such as the Hill Island assemblage and the Wall Lake group here. And there's also younger late Paleoproterozoic clastic basins and outliers of the NUNACHO and Tliucho group. The overarching goal of this project is to understand tectonic evolution and architecture of the western margin of the Ray Craton prior and during the assembly of Nuna supercontinent. And this is important because understanding plate tectonic processes that affected the western margin of the Ray Craton will help us understand and predict what type of ore deposits may have formed and the potential for their preservation. Fundamentally, we want to provide a robust geological framework through bedrock mapping as a base for thematic research. We selected an area along the Craton's margin around the Nacho Lake here, because it had the potential to reveal significant new information. The state of knowledge going into this project includes old geology maps of the NUNACHO map sheet, delineating the NUNACHO basin and outliers in gray and in green here. But notice that the basement rocks in pink are mostly undivided. The entire NUNACHO basin was mapped as part of a PhD thesis by Larry Aspler, and its black and white maps have been digitized by the NTGS. Even though there is very little baseline data available to guide exploration, several mineral occurrences have been discovered in the 70s. They're shown here by their main commodities, with uranium in green, rare earths in pink, copper in brown, nickel in yellow, lead in blue, and zinc in orange. And these occurrences have not been classified or assigned to a specific mineral deposit type. Other data sets available for the NUNACHO area include an airborne aeromagnetic survey conducted at 400-meter line spacing. Lake sediment samples originally collected in the 70s have been reanalyzed and show interesting geochemical anomalies. And with all of this information compiled, we conducted 3 summers of fieldwork with 1 more season planned for 2021. Our stations are shown here by the green dots, and they provide a coverage at 250,000 scale for the whole Nenacho map sheet, and also a more detailed coverage around the transect from the Porter domain of the South Ray Craton all the way to the Great Slave Lake Shear Zone here. And we also visited key sedimentary packages like the Hill Island assemblage and the Rutledge River Basin assemblage. And the yellow dots here are stations that were made during the 2015 and 2016 South Ray project funded by GSC's GEM program. Our goal is to publish a map at 1 to 250,000 scale of the Nenacho map sheet that will complement the South Ray maps to the east and will provide geological context for our thematic studies. In addition to providing an improved geological framework, the scientific questions that we're trying to answer are: what is the crustal evolution and what tectonometamorphic events affected the western margin of the Ray Craton? How did the Nenacho Basin form? Is it a single sequence? Where did the detritus come from? What driving forces led to opening and later deformation of the basin? Which type of mineral deposits formed? And what are the lithological and structural controls on mineralization? Each of these facets are being addressed by our university partners. We currently have 8 students from various Canadian universities. And for the remaining of this presentation, I will give very brief overviews of each of these research projects and encourage you to download the various posters and presentations that are available. Benjamin Neal is at University of Alberta working on his PhD degree with Tom Chaco and Larry Eman on the basement rocks to document the history of juvenile crust formation and subsequent crustal reworking. The goal of his project is to determine the timing and nature of magmatism to provide a model for the Archean to Paleoproterozoic tectonic evolution of the western margin of the Ray. Through extensive mapping, combined with uranium-led geochronology, including TIMS analysis, and various geochemistry study, including oxygen, hafnium, cerium, and neodymium isotope work, Ben is finding a suite of rocks, including rare preservation of Mesoarchean crust and Aerosmith age magmatism and metamorphism. He also extended the presence of 2.0 to 1.9 Tolson age magmatism far away from the actual Tolson magmatic zone. I invite you to download Ben's posters to find out more about the nature of the basement rocks. Another PhD project is just starting. Jordan Diane, under the supervision of Cathy Bethune at the University of Regina, has a project that focuses on Paleoproterozoic sedimentary sequence older than the Nenacho Basin that are preserved in various locations along the western margin of the Ray Craton. The goals are to characterize the sequences by determining their maximum depositional ages and provenance and source of the detritus in order to provide a tectonic model at time of deposition. This past summer, we mapped a possible outlier of the Hill Island assemblage here, and we also visited the original location where the Hill Island assemblage was defined. Jordan's work will include uranium-led geochronology on detrital zircons and hafnium isotopes on selected zircons, as well as geochronology on cross-cutting dikes to constrain the timing of deposition of the sequence, and argon-argon thermochronology on biotite to determine the timing of metamorphism, as well as geochemistry of the mafic volcanic rocks to characterize their tectonic environment and potential for hosting base metal mineralization. Initial work for Jordan will focus on outliers of the NWT here, but will expand into Saskatchewan and Alberta, looking at the time-correlative Wally group in order to provide an improved geodynamic model for the western margin of the Ray Craton during the early to mid-Paleoproterozoic. Under the supervision of Alessandro Yelpi at Laurentian University, Jade Lockie has started a BSc and will continue onto an MSc project. Her research will focus on the younger, mid to late Paleoproterozoic Nenacho Basin. The goals are to reevaluate the sedimentology and stratigraphy of the Nunatchu group, resolve the basin provenance, and produce an updated geodynamic model for the Nunatchu basin. Through targeted fieldwork, extensive uranium detrital zircon geochronology, provenance studies, detailed stratigraphy, and paleocurrent analysis, Jade will provide an improved understanding of the Paleoproterozoic evolution of the western margin of the ray by documenting the depositional history of the Nunatchu basin. I encourage you to download her poster, which will show some of the preliminary interpretations. Rebecca Conam is conducting research for her MSc degree at Simon Fraser University under the supervision of Dan Gibson and Don Kellett. Her research focuses on the post-assembly structural evolution and thermal cooling history of the western margin of the Ray Craton. The goals of this project are to identify major domain-bounding structures and document the exhumation history of the various crustal blocks. Through extensive field mapping, structural analysis, and petrography combined with uranium-led geochronology, Rebecca delineated new structures and documented sinistral strike-slip kinematics post-deposition of the Nunatchu group as young as 1820 MA, followed by late dextral kinematics. Rebecca is patiently waiting for the results of her argon-argon thermochronometry of a transect between the Porter domain here and all the way to the Great Slave Lake Shear Zone. Here is a snapshot of Rebecca's poster, which I encourage you to download. We also have an undergrad student, Nancy No, conducting a directed study with Brian Cousins at Carleton University. Nancy's work is to characterize the northwest trending dikes that cut the Nunatchu group and compare them to the Sparrow dikes and other northwest trending dike swarms in the Tolson Amati Zone and the Ray Craton. Through field observation, thin section work, as well as geochemistry and neodymium isotope work, Nancy will provide an improved understanding of the tectonic setting, nature of the mantle, and potential link between magmatism and mineralization. These dikes cut shear zone in the Nunatchu group rocks, and dating them will give us a minimum age on ductile deformation. That will be part of Rebecca Conam's project, and Nancy will have completed her directed study this winter. We also have initiated 3 research projects in collaboration with Aaron Adlaka and Jacob Henley at St. Mary's University in order to address questions around mineralization style and timing, source of mineralizing fluids, and extent of mineralization. There are several mineral showings around the Nunatchu Lake area. The main commodities are uranium, rare earth, as well as copper, lead, zinc, silver, and gold. But there's very little known about the style of mineralization and the controls on distribution of the ore. One MSc project is focusing on the uranium mineralization. Kirsten Landry, under the supervision of Aaron Adlaka, aims to characterize uranium mineralization and alteration facies, determine physicochemical conditions and absolute age of ore formation, and determine sources for metals and fluids. Kirsten has visited several uranium occurrences and collected trench and core samples. She is characterizing the mineralization through petrography, geochemistry, and isotope work, and also want to try and constrain the relative and absolute timing of uranium mineralization by doing uranium lead on uraninite, titanite, and apatite, as well as rhenium osmium dating of molybdenite. Kirsten is developing a paragenesis of the uranium mineralization and classifying the styles of mineralization into a genetic model to improve our global understanding of Paleoproterozoic basins hosting uranium. Kirsten has a presentation on her preliminary results, which I encourage you to view. Dr. Aaron Adlaka has another student, Andre Ouagaran, whose PhD work will focus on characterizing the iron oxide mineralization and investigate the source of hydrothermal alteration that appears to be spatially associated with the mineralization. Through fieldwork and a series of geochemical, geochronological, and petrographic studies, Andre will develop a paragenesis for the iron oxide mineralization, and characterize the hydrothermal alteration, discuss potential link to uranium and/or copper mineralization, and see if the alteration assemblages observed around the natural basins share any similarities with the iron oxide copper-gold deposit. Andre has a poster that I encourage you to download. An MSc project has been initiated to focus on the polymetallic copper, lead, zinc, silver mineralization. Anna Tarakova and her supervisor Jacob Henley at St. Mary's University are looking at drilled showings in the natural area to determine the style and timing of copper mineralization, assess the structural controls on mineralization, and determine fluid and metal sources and conditions of mineralizing fluids. Through a wide-ranging series of analytical techniques, including fluid inclusions, isotopes, geochemistry, and uranium-osmium dating of molybdenite, Anna will answer fundamental questions regarding copper mineralization along the western margin of the Ray Craton, such as, is the source of the metals magmatic? Are there any relationship with the uranium mineralization? And does the copper mineralization around the natrolite share similarities with copper porphyry deposits? Anna has a presentation that will answer these questions, which I encourage you to view. In summary, the aim of the Natural project is to improve our understanding of the tectonic evolution of the western margin of the Ray Craton by providing a geological framework and piecing together the various parts of the story. Because understanding plate tectonic processes will help us understand and predict what type of ore deposits may have formed and the potential for their preservation. There are many students and profs involved in this project, and I would like to thank them all for their contributions, and also my co-workers at the NTGS, Hendrik Paul, Beth Fisher, and Bernadette Knox, and at the GSC, Sally Pearson and Daniela Regis. We are looking forward to one last field season for the Natural project.